This video is another demonstration of graphing a polynomial inequality, and this particular example is going to be a polynomial inequality in the standard form. I did another demonstration where I did it in a vertex form. Okay, now again, what is a polynomial inequality? You basically have some kind of a polynomial, in this case a trinomial, a quadratic trinomial, and you're going to have it greater than or equal to 0, so you have an inequality involved. Okay, now how do we do this? How do we sketch this? Well, the first thing we need to do is actually sketch this particular parabola. Okay, so if we're going to do it in the standard form, we're going to say that a is equal to 1. It's the coefficient in front of the x squared. B is equal to 5, or the coefficient in front of the x, or the linear term. And c is the constant. In this case, it's 4. Now, what can we get from the a, the b, and the c? Well, basically, there's a lot of information. We can find what the vertex is. And remember, the vertex in any kind of a quadratic polynomial is going to be a parabola of some kind, isn't it? So we're going to get the vertex as negative b over 2a, and the y value is going to be 4ac minus b squared over 4a. Okay, now let's go ahead and plug in our numbers so we can get our vertex. I'm going to get a negative 5 over 2 times 1. That's going to turn out to be a negative 5 over 2. Well, let's just keep track of our steps there. Okay, so my x value is going to be a negative 5 halves. What's my y value going to be? Plug in the numbers. 4 times 1 times 4 minus 5 squared. Okay, all over 4 times 1. That's going to give me 16 minus 25 over 4, or negative 9 fourths. And let's just bring the x down there. Okay, so according to this, my vertex is going to be a negative 5 halves, a negative 9 fourths, about 2 1/2 and 2 1/4. Let's just do a quick sketch over here and see where that might be located. And let's just go over about 2 1/2. Let's go down about 2 1/4, and we'll just say that that is our vertex. Okay, beautiful. Now what do we have to sketch? Well, the other thing we probably want to include in this is where this is going to cross the y-axis. Okay, and remember how you find the y-axis or the y-intercept. It's just the c value, and in this case c is equal to 4, which would be the point 0, 4. Okay, so again we're going to estimate it being right about there. Okay, now I'm starting to get an idea of what my parabola is going to look like. It looks like it's going to go upward, and I can verify that by looking at my a. Remember that you can figure out the direction of your parabola just by looking at the a and see whether it's a positive or a negative. If it is positive, which it is in this case, my parabola goes upward. If my a is negative, it goes down, like in that direction. And in this case, like I said, it's actually going to be a positive 1. So let's go back to up to our quick sketch, and let's kind of estimate where that parabola, or what that parabola is going to look like. So that looks pretty decent. We're still not quite done. We still have to figure out where our x-intercepts are. Okay, and in this case, we're in a little bit of luck. Let's just go ahead and do x-intercepts. Remember, you want to keep track of all your work, and if you look at this from on high, you can see that I've got everything labeled. Here's my vertex, y-intercept, direction, and here are my x-intercepts. I'm lucky for this particular example because x squared rather plus 5x plus 4 greater than or equal to 0 can be factored as x plus 4, x plus 1, which means that my x is equal to a negative 4, or my x is equal to a negative 1. And that's actually borne out by my quick sketch here, isn't it? It looked like my x is going to be a negative 1, 0, and my x is going to be a negative 4, 0. Now, if I just wanted to sketch this as an equality, this would be my parabola. But don't forget, it is a inequality. So I've got some shading to do, basically. Now what I need to consider is that since my parabola divided my x-axis into basically 3 regions, I've got three regions to test, okay? So I want to see whether I'll be shading inside or outside. Now my first region is everything from negative infinity to a negative 4. Now how do I know that? We'll just go up to the x-axis and notice that everything over here is a possibility. It goes up to and includes negative 4 because I have an equal sign. All right. My second region that I'm going to test is from negative 4 to negative 1. Negative 4 to negative 1. And I'm going to put includes all of those as well. And you can see why, even though there's an overlap here, one of those will disappear, and I'll show you why in a second. And my third region is negative 1 all the way up to positive infinity. There we go. Now let's go ahead and test a point out of each one of those and see what we get. All right. If I were to choose something like, let's just test negative 5, because that's in there somewhere. If I put negative 5 into my equation, I'm going to get negative 5 squared plus 5 times a negative 5 plus 4 is greater than or equal to 0. Let's see if that's true. I get 25 minus 25 is 0, plus 4 is positive, so I end up with 4 is greater than or equal to 0. Is that true? And the answer is yes, it is true. So I get to shade everything all the way up to and including negative 4. Let me just put a solid dot around there, all right? Now, when I test a point from the next region, which is between negative 4 and negative 1, so let's just try something like a negative 2. I'm probably not going to get this to work, but let's just see. So I'm going to put in negative 2 and squared plus 5 times negative 2, right, plus 4, and I'm going to hope that that's greater than or equal to 0. Let's see if it is. I'm going to get 4 minus 10. Whoops, it doesn't look quite right there. Let me just rewrite that. I'm going to get 4 minus 10 plus 4 is greater than or equal to 0, and that's not going to actually work, is it? I'm going to get negative 6 plus 4 or negative 2 is greater than or equal to 0. That's actually okay, because that means I'm not going to shade what's inside here, and I don't have any overlap with my negative 4s. Now I'm going to try one more point. I have to test the third region, and you can probably guess that it is going to be shaded. Let's try let's try 0, because 0 is outside there, isn't it? So let's put 0 into our equations. 0 squared plus 5 times 0 plus 4 is greater than or equal to 0, actually. So I'm going to get 5 times 0, which is 0, plus 4. So again, I get 4 is greater than or equal to 0. And again, that is a true statement. So now I'm going to go back up to my graph and shade everything in that positive direction. And again, blacken in my circle, because negative 1 will actually work there. I'm not quite finished here, though, because I've got along the x-axis, but now I need to find along the y-axis. All right? That's a much easier proposition. Just go to your equation. This is saying it wants all the values greater than 0. And remember that this, in a standard form, this is just basically equal to the y. So it's like replacing all of this with y. Y greater than 0 is shading upward. So you go to where y is 0 and shade up. And so we're going to do this, and we're going to do that. Now notice we're not going to shade inside there, because we already proved that inside the parabola it's not going to work. Basically everything inside this shaded area is going to make my parabola true. All right? I hope that helped. Just remember to try your test points and to go after and make sure that you sketch your parabola correctly. All right, good luck to you.